So today I'm going to talk about data centers and the crosshairs, the top data center attacks, and what I'm going to just go over at a high level for time, but I'll give you a glimpse into what you should be most concerned about. So I'm going to talk about DDoS attacks, DNS exploits, web application attacks, authentication weaknesses, and then I'm going to briefly give you an overview of solutions that can help protect your data center. So DDoS attacks. It's not a matter of if, but when you will be attacked. So here's a couple just high-level information about recent DDoS attacks. It's still the usual suspects. SYN flood attacks still account for the majority of attacks today. A lot of the attacks today are still volumetric attacks, where organizations try to just flood your network or your applications with traffic. There is a small number of application attacks. HTTP GET is the #1 application attack. You also have Solaris and other more specific types of attacks. One thing that's interesting to note that we've seen emerge in the last half of the year is SSDP attacks, which is using a protocol, a plug-and-play protocol that's used by routers and printers and network devices to connect to other devices, and they're being used for reflection attacks. So basically what's happening is that attackers are able to get access to these devices, because many of the devices have default passwords, get control of them, and then launch attacks from them. And then their requests might be small, but the response is much, much greater, and this response goes to the targeted site and overwhelms them. And what's interesting, this is the first example really of IoT type attacks. And I think that as more and more devices get connected to the internet, and as more and more users don't bother to change their default settings, you're going to see a lot more of these types of attacks. Another interesting thing that happened a couple of weeks ago, you guys may have heard of it, the Great Cannon of China. So basically what happened, if you're not aware of it, China has this great firewall of China where they look at all traffic. And there's a lot of organizations that are trying to find ways around the firewall. China doesn't like that. So what happened is that they went and attacked 2 projects on GitHub that were trying to show users how to basically bypass the firewall. And what they did, to perform their attack, they injected JavaScript into Baidu, I hope that's how you pronounce it. They're the search engine, the big search engine in China, web traffic. So an innocent user that was going to the Baidu website for a search didn't realize it, but they're actually accidentally performing a DDoS attack on GitHub. And that amount of traffic flooded GitHub's site, took it down. And that's just an example of the power that can happen. And if China wanted to, they could obviously take down many, many, many sites through this mechanism. So I think we could start seeing more of that. I don't know if this is the first example of a state-sponsored attack. There were other attacks. There was attacks on North Korea that took them offline. We don't know exactly who is responsible for it, but I think that we can start seeing more state-sponsored attacks going forward. Now we're going to talk about another area of concern, which is DNS servers. Most data centers host DNS servers, and DNS servers are a target of attack for several reasons. First of all, attackers will try to take the DNS servers offline, because once they do, users can no longer access vital services. So once the DNS servers are offline, if you're, say, like a internet ISP subscriber, you can no longer access the internet because you can't access vital web application services, vital email services, because you can't resolve the IP address or the domain names. Another area of concern is DNS reflection attacks. That's where DNS servers are really not the target of the attack. They're more of the weapon in the attack. Because what happens is that people will try to attack other sites, and they'll use DNS servers as the conduit for the attack. So they'll send a request to a DNS server and then direct the response to the target. But the DNS server ends up a lot of times being affected by those DNS attacks. So you need to have a way to prevent those DNS reflection attacks, also called amplification attacks, from happening. And the third threat is DNS cache poisoning, which is designed to redirect legitimate traffic to malicious sites. And I'm just going to very quickly describe what a DNS amplification attack is. Basically, it's where you've got remotely controlled bots that that pretend to be from the victim's website, and they send a very small DNS query to a DNS server. The DNS server responds back with a much larger response to what it thinks was a source, but is really some innocent site that's being targeted for a DDoS attack. But what happens in this attack is the DNS server gets bombarded with traffic in carrying out the attack. So you need to make sure your DNS servers can't be used to perform these DNS attacks. The next thing we're going to talk about is web application attacks. So pretty much every data center has web applications, and they are a top target of attack. And what we've looked at and we've seen is that the attack sources change over time. If you look at 2013, the big headlines were a lot around hacktivist attacks. It was either anonymous attacking different government sites, and then there were a lot of attacks in 2013 from groups based in the Middle East that were trying to target a lot of banking sites that they felt were contributing to, they wanted to try to take organizations offline because of a video that was on YouTube that they disliked. So there was a whole bunch of hacktivist attacks in 2013. There was a lot of hacktivist attacks also related to turning web servers into DDoS attack sources. But what we've seen in 2014, a lot less hacktivist attacks, but a lot more cybercrime. So we've seen a lot more of your standard SQL injection attacks, as well as attacks designed to compromise the users that are visiting the websites. So a couple of web application risks by the numbers. 96% of all applications have, or have at some point in their history, been vulnerable to web attacks. And so you can assume that at some point your website is going to be vulnerable. You need to do something to protect it. 80% of website breaches for retailers are due to SQL injection. SQL injection has been around for many, many years, but it's still a top target, or still top type of attack. It's still a very lethal type of web attack. And then the next thing we're going to talk a little bit more about in the next section is something that's kind of simple, but it's actually what a lot of cyber criminals use to get money and to perform their malicious deeds. And that's that they'll try to compromise the users who are accessing the websites, get their credentials, and then log in to their, say, their banking sites, and then steal money from their banking sites. So that's kind of arguably a web application threat as well as an authentication weakness. So this is very, very common, where what attackers will do is they will create phishing. I'm sure everyone in this room has gotten an email of trying to get your credentials, your username and password to your banking site, pretending to be your bank. What they do with that information is then, once they've got your username and password, they go to the online bank or the eBay or whatever site and then use it to steal money. Another common thing that happens is they'll get brokerage information, and then they'll find a penny stock, they'll buy up a bunch of that stock with the brokerage account, and then they'll sell it at a loss, but then they've, on their site account, they've made money. So there's lots of different ways that attackers use phishing to be able to steal money. In addition, there's a lot of attackers that use password guessing, because many, many users use very basic passwords. So I think that the most common password used is like 1, 2, 3, 4, 5, 6. So very basic passwords are used by many, many people. Passwords also a very common password. So it's very easy for hackers to be able to break into accounts. And then the third risk is that most of us, including myself, use the same password across many sites. So if one of those sites is compromised, then cyber criminals can take that information and go and test those usernames and passwords on other sites and use that to log in and steal money. The solution is to require strong passwords and enforce dual-factor authentication, and then perform fraud detection to look for users logging in from different locations and such. So what do we do to help protect against the top data center threats here at A10? We have an integrated web application firewall, which can help stop web attacks and protect your web servers. We have our AAM, or Application Access Management, which provides authentication, helps you provide dual-factor authentication in your apps, making them more resilient to different types of password guessing and attacks. Our SSL Insight technology, which I didn't talk about today, but it's a really important way to inspect SSL traffic. Our DDoS protection and our DNS application firewall, which help protect your data center, all of your servers in your data center, and your DNS servers. And then we also have very, very high performance IPsec VPN for encryption. That's just a high level of what we do. And one thing I'd mention is that we set ourselves apart by our very high performance, and all of these features are included standard with our load balancers. So you get all of these features without having to pay extra licensing for them. And they're very, very secure, ICSA certified, and very granular and secure.